Today's lesson is on literal equations. So first, what is a literal equation? Well, it is, or they are, I guess, equations with more than one variable. So typically, when we see an equation, at least so far, there has only been one variable. So, if there's an x in the problem, I'm going to have to solve for x, and I don't even really need to read the question. But literal equations have multiple variables, and so it becomes even more important that you read those directions to figure out what you're going to solve for. Specifically, what's a formula? A formula would be an algebraic equation that relates two or more real life variables. So, for example, a formula we've been using a lot lately is area. Area of a rectangle we know is length times width. And if I wrote on a piece of paper A equals L times W, everybody would know what A, L, and W stood for. That is a well-known formula. All right, what are our steps for solving literal equations? The first thing you want to do is circle the variable we are solving for. So again, in a literal equation, there's multiple variables, so you need to make sure to keep track of which variable you want to solve for. And then step 2 is use inverse operations to isolate the circled variable. All right, so let's go ahead and try some problems out. Okay, so our first equation is asking us to solve for W, and they've given us the equation A equals LW. Well, that's area equals length times width. That is the formula for the area of a rectangle. So they've asked us to solve this equation for W. So according to our steps, the first thing we want to do is just circle the variable. I'm solving for W, so here's W. So I'll use a different color. And then I want to solve for it. So think about what we've been learning the last couple days. If I have two things next to each other, what operation is that? Well, that's multiplication, right? So if I want to get rid of multiplication, if I want to get rid of this L, the inverse of multiplying is dividing. So I'm going to divide both sides by L. I'm going to switch it to an uppercase L so it's a little easier to tell it's a L and not a 1. So dividing both sides by L, so L divided by L will cancel out. What about over here? What do I do with A divided by L? Well, nothing. A and L are not like terms, they're different variables, so there's not really anything to do except leave it as a fraction. And I'm done. I have solved this equation for W. So this next problem is asking us to solve for F. You may or may not recognize this formula, but this allows us to convert temperatures from Fahrenheit to Celsius. So if I put in a Fahrenheit temperature, I'll get Celsius, and they're asking us to solve for F, so that would allow us to go the other way, put in a Celsius temperature and get Fahrenheit. So here's the variable that I want to get by itself. Let's go ahead and solve this. I'm going to show you two different ways that you could do this problem. First one looks more like what we've been doing so far in class. I can distribute the 5/9. Unfortunately, we don't get a super nice looking answer here. It's 5/9 F. And then if I do 5/9 times a negative 32, we do normally like to look for common factors. However, the only factor of 9 is 3 and 9, and 32 is not divisible by 9. So we're not going to be able to reduce this fraction. So we're just going to have to multiply, and we end up with a negative 169ths. Not the nicest. All right, well then I'm going to continue to get F by itself. Here's my F term. I want to get rid of this fraction. It's being subtracted here, so the inverse of subtracting something is going to be to add 169ths on both sides. Now again, these are not like terms. I can't actually add c and 169ths, so I'm just going to write c plus 169ths equals 5/9 f. All right, from there I have to get rid of this fraction. I'm going to do it in parts so that you could multiply by the reciprocal if you wanted to. I'm going to multiply by 9, but you have to be careful here because I want to multiply this entire side by 9, not just the first thing. So if I'm multiplying the whole side by 9, we're going to have to use parentheses here. So that 9 cancels with that 9. I get 9c equals, oh look, those 9s cancel. Sorry, that should not be equals, that should be a plus. 9c plus 160 equals 5f. And then we're going to divide by 5. So everything gets divided by 5. And remember from a previous lesson that this is the same as writing it as 9c divided by 5 plus 160 divided by 5. So 9c divided by 5, I can't reduce that. You can leave it like this, but usually you'll see it written as 9/5 c. Usually if we have a variable with a fraction, we will pull the variable outside like this, so it looks like 9/5 times c. And then 160 divided by 5 is going to be 32. And then I'm done. That's my answer. I've solved it for f. Now here's another way you could do the problem. So another thing you can do is instead of multiplying out that 5/9, keep in mind that the whole entire thing is being multiplied by a value, and so I can just get rid of that 5/9. Well, how can I get rid of that fraction? Well, I can just multiply both sides by the reciprocal. And again, you could do it in two parts, multiply by 9 and then divide by 5. So my 9s will cancel, my 5s will cancel, and I end up with 9/5 c equals f minus 32. And then all I have to do is add 32 on both sides, and you get 9/5 c plus 32. Again, they're not like terms, we can't actually add them, equals f, which is the same answer I got earlier, just a little bit faster. And number 3, solve for n. Here's n, I need to get that by itself. Now remember, we cannot pull things out of fractions, so you cannot deal with that x until you get rid of the 3, because in a fraction we have invisible parentheses grouping that numerator together. So to get rid of a divided by 3, I'm going to multiply both sides by 3 to get 3m equals x plus n. And then I need n by itself, so I need to get rid of x. To get rid of my x, I'm going to subtract. And again, I can't actually combine those. They're not like terms, so it's just going to stay as 3m equals, 3m minus n. Let me get my eraser. 3m minus x equals n. And you can always rewrite it with the n in the front if you want. All right, my next slide, we're talking about what a function is. A function is an equation with two variables where one variable is isolated on one side of the equation. I'll make this a little bigger. And we are also going to be spending a whole unit next unit talking about functions, but for now that's enough. So first we're going to rewrite so y is a function of x. This means we're going to solve for y. Essentially, when it says this sentence, you're going to rewrite so that first variable is what it equals. And then when we get to the second set, it says rewrite so x is a function of y. This means you will be solving for x. So again, whatever that first variable is, that's what you're solving for. Let's go ahead and do those 4 problems. All right, so our first one here is 5x plus 2y equals 5, and we want to rewrite this one so that y is a function of x, which means we're solving for y here. So if I want to get y by itself, I want to get this term by itself first, so I don't need that 5x. I'm going to subtract that whole term on both sides. So that cancels out. I've got 2y over here. And then when we do functions, we typically put the variable term in the front and the constant, that plain number, second. So I'm going to write negative 5x first and then plus a 5 because the 5 is positive. Then I want to get rid of that 2. So I'm going to divide everything by 2. And remember, if I divide two things by 2, we can rewrite it like this, but that can then be broken down into two separate fractions, like so. So if you have a fraction with the variable, you will typically see the variable pulled out of the fraction where it is next to the fraction, which does mean the same thing as if it was in the numerator, and that is your answer. Now, occasionally on a multiple choice question, you might see it written as one big fraction like this. For functions, this is what we're going to prefer. But again, if it's multiple choice, this is still a correct answer. Now let's do the second one, which is 4x minus y equals an 8. So same steps, I'm rewriting so y is a function of x, so I'm trying to get the y by itself. First, I'll get rid of these x's by subtracting that whole thing on both sides. I'm left with a negative y equals, and again, I'm going to write the x first, so negative 4x, and then a positive 8. And then I need to get rid of this negative in the front. And remember, if there's no number, it's an invisible 1. So everything's going to get divided by a negative 1. And that will leave me with negative divided by negative is positive 4x minus 8. Now let's go the other way. Rewrite so that x is a function of y. So this time I'm going to take those same equations, but solve for x. So here's my x term. I want to get rid of that y, so I will subtract 2 y's on both sides to now have 5x equals. Again, I'm going to put my variable part first, so that is a negative 2y and a positive 5. Now I'll divide both sides by 5 to get x by itself. And again, you may see it written as a big fraction, but we want to break it down, so I'll rewrite it as a negative 2/5 y. Again, that can't be reduced. And then 5 divided by 5 is just a 1. So negative 2/5 y plus 1. Last one is 4x minus y equals 8, rewriting so that x is a function of y. Get my x term by itself by getting rid of that y, plus y on both sides. 4x equals a y plus an 8. Again, variable first, then the constant. Get x by itself, divide everything by 4. So again, you might see one giant fraction, or we can break it down. Y over 4 plus 8 over 4. Well, 8 over 4 is just 2. What about this? Again, we want to pull the variable out of the fraction like so. My denominator is a 4. Well, what goes in the numerator? Remember, anytime there's no number with the variable, there's always a 1. So that's 1/4 y plus 2.